Okay, Math 8, we are going to continue with modeling equivalent fractions. So first we need to define what equivalent fractions are. Equivalent fractions are fractions that have the same value. So if we look at these fraction bars, these are called fraction bars. You're going to need to know that later. Fraction bars. Then you can see that equivalent fractions take up the same amount of length on the fraction bars. So 1 is not a fraction, but it is a whole number or an integer. But 1/2 is a fraction. It takes up 1/2 of the length. 2/4 is equal to 1/2. So those are equivalent fractions. 1/2 is equal to 2/4 because they take up the same amount of space on the fraction bars. Similarly, 2/2 is equal to 1 because they take up the same amount of space on the fraction bars. So let's look at this next example. We have 1, and then we have that divided into halves, and then we have those divided into, each of the halves is divided into a third, but the total bar is divided into sixths. So how many sixths are equivalent to 1/2? 1, 2, 3. Therefore, 1/2 is equal to 3/6. 1/2 and 3/6 are equivalent fractions. So that's what's meant when we use the term equivalent fraction. So let's look at some examples here. Example 4.13. Use fraction tiles, I said fraction bars up ahead, above. Use fraction tiles to find equivalent fractions. Show your result with a figure. So I've given them here for you, so all you have to do is fill them in. So we're going to start just like the ones in our example up above were. We're going to start with 1, and we want to know how many eighths equal 1/2. So the first thing we're going to do is we're going to roughly divide this into 1/2. It doesn't have to be perfect. We're going to label this 1/2, and this is going to be 1/2. And then we need to divide the whole into eighths. So I'm going to divide this bottom one into 8 pieces. The easiest way to get them somewhat even is to divide in half, and then divide each of those into half again, and that's fourths. And then divide each of those into half again, and that's eighths. And you can tell it's very rough. They're not even close to being equal, but approximate. And each of these is 1/8, 1/8, 1/8, 1/8. Okay. So the question is, how many eighths are equal to 1/2? So to figure that out, we would see that this, let me make this a little thicker, that this is 1/2. So how many eighths are equal to that? Well, let's count them. We have 1, 2, 3, 4. So 4/8 are equal to 1/2. Let's do the same thing with this. How many tenths equal 1/2? So if this is 1, then this is going to be 1/2. Then I need to divide the bottom one into tenths, which means I'm going to divide this into half, and then I need to have 5 sections on each side of that half. And once again, it's going to be very rough. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 sections. So now we have 1/10. Each of these is 1/10. I'm not going to write it in all of them, but you get the idea. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are all 1/10. So how many tenths are equal to 1/2? Well, here's 1/2, and we have 1, 2, 3, 4, 5 tenths. So then we can write 5 tenths equals 1/2. Third, how many twelfths equal 1/2? So if this is our 1, and we're going to divide this one into half again, and half. Now we need to divide this into twelfths. So if I divide it into half, then I need 6 on each side of the half. And divide that in half again and divide these into thirds. And that will give me 12 sections total. 1/12, 1/12, and so on and so forth. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so those are 12s. So how many of these is equal to 1/2? Here's 1/2. We have 1, 2, 3, 4, 5, 6. 6 of these, 6/12 is equal to 1/2. Okay, so this is what equivalent fractions are. Fractions that have the same value. Okay, moving on to the next page. The equivalent fractions property. The equivalent fractions property is looks very similar to one of the other properties that we've seen before. Let's go ahead and write it out. It says that A over B is equal to A times C divided by B times C. Which property does that look like? It looks a lot like the multiplication property of equality. I'm going to go ahead and jot it up at the top here just so you remember what the multiplication property of equality is. It says that if A equals B, then A times C is equal to B times C, right? If you multiply both sides by the same thing, it does not change the equality. Same thing is true for the tops and the bottoms of fractions. If you multiply the top of the fraction and the bottom of the fraction by the same number, then you still have an equivalent fraction. The one thing to note here is that B cannot equal 0 and C cannot equal 0 because we cannot divide by 0. It's impossible to divide anything by 0. But other than that, if you multiply the top and the bottom of a fraction by the same number, then you still have an equivalent fraction. So let's look at the pizzas here. On A is half of a pizza, but we can also say that that is 4/8 of a pizza. So let's use the equivalent fractions property to get that. If we start with half of a pizza and we multiply the top times 4 and we multiply the bottom times 4, then we get 4/8. So these are equivalent fractions. Let's do some examples. Example 4.14. Find 3 fractions equivalent to 2/5. Find 3 fractions equivalent to 2/5. So since we just have to multiply the top and the bottom by the same number, this is pretty simple to do. So let's start with 2 times 2 over 5 times 2. So I'm multiplying the top and the bottom by 2, and I get 4/10. So there's one of our equivalent fractions. I can also do the same thing by multiplying times 3. And starting with 2/5, multiply the top times 3 and multiply the bottom times 3, and I get 6/15. So 6/15 is an equivalent fraction to 2/5. I can also multiply times 4. 2/5, multiply the top times 4, multiply the bottom by 4, and you get 8/20. So these are 3 equivalent fractions to 2/5. And of course you could do any number, right? I just picked 2, 3, and 4 because they're easy. I could pick 10. 2/5 and multiply the top by 10, multiply the bottom by 10, and I get 20/50. And this is also an equivalent fraction. Okay, so it can be any number as long as you do the same thing to the top and the bottom. Example 4.15. Find a fraction with a denominator of 21 that is equivalent to 2/7. Okay, so we want the denominator to be 21 and we want it to be equivalent to 2/7. So let's go ahead and write our fraction here, 2/7. and then we want to multiply the top and the bottom by the same thing such that the denominator of the new fraction is 21. So 7 times what is 21? And the answer is 3. So if we multiply the bottom times 3, then we also have to multiply the top times 3, and we get 6. So 6 over 21 is an equivalent fraction to 2/7 and has a denominator of 21. So that is how you get an equivalent fraction with a specific denominator. Let's move on to numbers on the number line. Locating fractions and mixed numbers on a number line. So this gets a little tricky for some students. So let's go through this explanation first before we get on to the example. So we're going to locate 1/5, 4/5, 3, 3 1/3, 7 4ths, 9 halves, 5, and 8/3 on a number line. So I'm not going to go in order to do this. Okay, I'm going to do the easy ones first. 3 and 5 are really easy because they are whole numbers. So I'm going to go ahead and mark 3 on here first. I'm going to put a dot at 3, and I'm going to mark 5 on here as well. 3 and 5. Okay, I'm going to cross those out because I've already taken care of them. Now it gets a little trickier because we have fractions. So let's go ahead and let's start with these bottom ones, these lower ones. We have 1/5 and 4/5. So these are the only proper fractions here. Proper fractions are all less than 1. So we know that they're going to be between 0 and 1. Notice they have the same denominator. That makes it a little easy. So they are both fifths, 1/5 and 4/5. So we need to divide the space between 0 and 1 into 5 sections, roughly. 1, 2, 3, kind of. 1, 2, 2, 3, 4, 5. Not super even, but you get the idea. So the first one is 1/5. So from 0, I'm going to move 1, and I'm going to put my dot there for 1/5. And then I can label that 1/5. I didn't bother to label 3 and 5 because they're already labeled there. And then, cross that out, and then I need 4/5. So I'm going to start at 0, 1/5, 2/5, 3/5, 4/5. And I'll go ahead and mark that. 4/5. Okay, so I've taken care of that. Let's move on to 3 1/3. So if I have 3 1/3, that means it's larger than 3, right? I have 3, 1, 2, 3, and then another third. So what I want to do is I want to roughly divide the space between 3 and 4 into 3 sections. And if I'm dividing it into 3 sections, I need to draw 2 lines to get 1, 2, 3 sections. Okay, so for 3 1/3, 1, 2, 3, and then another third. I can go ahead and mark that one. 3 and 1/3. Okay, cross that out. Now, for improper fractions, it's easier if you convert them into mixed numbers. Now, I said it was easy. It's usually easier to keep them as improper fractions in case you have to compute with them later, but in this case, we're not computing, we're graphing, so let's go ahead and convert them. So 7 fourths, we need to convert that into a mixed fraction. So the way we did it in class, if this is the way you want to do it, that's fine. If you can just do it visually, that's fine. 4 goes into 7 one time. 1 times 4 is 4. I'm going to subtract, and I have 3 left over. That means my mixed fraction, let me just draw some arrows so I know where I'm going here. My mixed fraction is 1 3/4. Okay, so if it's 1 3/4, I know it's bigger than 1, but smaller than 2. So I'm going to come up to the 1. And then I have to divide that space between 1 and 2 into 4 sections. So roughly 4 sections. So I'm going to go from 0 over 1 and then 3/4. 1, 2, 3/4, and here is my graph, 1 and 3/4. Okay, so with improper fractions, change to a mixed number. Let's do 9/2. 9/2. 2 divided into 9. 4. 4 times 2 is 8. Subtract, and I have a remainder of 1. So this mixed fraction is going to be 4 and 1/2. So I'm going to go halfway between 4 and 5. So right here. 4 and 1/2. And lastly, 8/3. 8/3, and divide 3 into 8. Goes evenly 2 times with a remainder of 2. So my fraction is 2 and 2/3. So I'm going to go past 2 but before 3. I'm going to divide that space into 3 sections. 1, 2, 3. So I go from 0, 1, 2, and 1/3 and 2/3. And here is 2 and 2/3. Okay, so that's how you graph fractions and mixed numbers on a number line. So example 4.16. Locate and label the following on a number line. So go ahead and pause it here, do it on your own, and then watch me do it and check your answers. So I'm going to go ahead and solve these really quickly because hopefully you've already solved them on your own. So I'm going to go ahead and do 3/4. So that would be right here. I'm going to divide that into 4s. 3/4. 4/3 is equal to 1 1/3. So I'm going to divide this into 3s. 1 and 1/3. And if that's 4/3, then this is 5/3. Notice I did that without even having to change it into a mixed number because I knew 1 more third would be 5/3. Okay, 4 and 1/5, so it's bigger than 4. I'm going to divide that space into 5. 1, 2, 3, 4, 5, roughly. Not very good, but good enough. So 4 and 1/5 goes here. 4 and 1/5. And then I have 7/2. 7/2 is equal to 3 and 1/2. So I'm going to go 3 and then halfway between 3 and 4, and that's where my dot is going to be. 7/2. Okay, so if you didn't understand why I did all that, I kind of skipped a few steps to speed it up, but you can go back up to the top of the page and watch that part again when I went step by step. So let's look at negatives. Like whole numbers, fractions have opposites. So remember, negative numbers are opposites of positive numbers. Thinking of negative fractions as the opposite of positive fractions will help locate them on a number line. Okay, and I know students really struggle with negative fractions and subtracting fractions. So let's look at this. If we have, let's say we have 3/4 and negative 3/4, then we can find these on the number line. It's easiest to find 3/4 first. So we know that that's going to be less than 1 and it's positive. Divide this into 4 sections. So 3/4 is 1, 2, 3 of the 4 sections. Okay, so we can look at the distance between 0 and that. Negative 3/4 is going to be the same thing but the opposite direction. So instead of going from 0 and then going to the right, we're going to start at 0 and go to the left. Same exact procedure though, okay? Negative 3/4. So it's between 0 and negative 1. We're going to divide that space into 4 sections. And starting at 0, we're going to count negative 3 of those 4s. 1, 2, 3. And here is negative 3/4. And it has the same distance from 0 as positive 3/4, just in the opposite direction. So example 4.17. Locate and label the following on the number line. Go ahead and pause the video, do it on your paper, and then play the video to see if yours matches mine. So I'm going to go ahead and start with 1/4, and then I'll do the opposite, negative 1/4. So to do 1/4, I'm going to divide the positive section between 0 and 1 into 4 sections, and I just want one of those. So from 0, I hop over 1/4, and here is my 1/4. For negative 1/4, I do the same thing, except I go the opposite direction. Start at 0 and go to the left. One of those fourths, negative 1/4. So there I've graphed 1/4 and negative 1/4. Let's do 1 1/3 and negative 1 1/3. So positive 1 1/3, I'm going to start at the 0, go positive 1, and then I need one more third. So I need to divide the space between 1 and 2 into 3 sections. Okay, so positive 1 and 1/3. For the negative 1 and 1/3, I do the same thing the opposite direction. So I'm going to go a whole 1 to the left and divide the next section into 3. So negative 1 and 1/3. It's located right there. And lastly, 5/2 and negative 5/2. So let's change this to a mixed number. So our mixed number is 2 1/2. Okay, so from 0 for the positive, I'm going to go 1, 2, and another half of a space. 5/2. And then for the negative, I'm going to do the same, but in the opposite direction. 1, 2, and another half of a space. So here is our negative 5/2. So that is how you locate and label negative numbers on a number line. Okay, one more page. Ordering fractions and mixed numbers. Let's see if I can get it all on here. Okay, there we go. So inequality symbols can be used to order fractions. Remember, inequality symbols are less than, greater than, less than or equal to, greater than or equal to, and not equal to. In this case, we're just going to use less than or greater than right now. So order each of the following pairs using less than or greater than. So the way to visualize this is to see where they are in the number line. So we have negative 2/3 and negative 1. Okay. Negative 1's easy. I'm going to start there, and I'm going to put that on the number line. I don't even need to write it in because it's already there. But negative 2/3, that is a proper fraction, but it's negative. So that means it's between 0 and negative 1. So I'm going to divide that space into thirds. Okay, I'm going to start at 0, and I'm going to go 2 spaces over, 2/3 over from 0. Here's my negative 2/3. Okay, so remember, less than is more left on the number line, greater than is more right on the number line. So we're comparing negative 2/3 to negative 1. Okay, they're both negative, but negative 2/3 is to the right of negative 1. Therefore, negative 2/3 is greater than negative 1. It's a bigger number because it's more to the right. Okay, let's do negative 3 halves and negative 3. I'm going to go ahead and do negative 3 on here first. And actually I should have made this number line a little longer because negative 3 halves means you go negative 3 and then another half. So it should be probably about right here, roughly, is negative 3 and a half. So let's compare. Negative 3 and a half is to the left of negative 3, which means negative 3 and a half is a smaller number. So negative 3 and a half is less than negative 3. Let's do negative 3/7 and negative 3/8. Okay, so now we have both of these numbers are going to be between 0 and negative 1 because they are both proper fractions, right? They have smaller numbers on the top, but they have different denominators. So how are we going to do that? First, we're going to divide. We're going to divide this into sevenths. Let's see if I can do this. Sevenths is kind of hard. 1, 2, 3, 4, 5, 6, 7. It's not very great, but we're going to do 3 of those. So 1, 2, 3. So negative 3/7, and then if I divide that into 8s, let's see, I'm going to do it up here, there. If I do too many, 1, 2, 3, 4, 5, 6, 7, 8. Nope, I did it into 8. So 3 of those, 3/8 is going to be right here. Negative 3/8. Okay, so we're working in a tight space there. But you can see that negative 3/8 is slightly to the right of negative 3/7. So let's look at what we're comparing here. Negative 3/7 is it greater than or less than negative 3/8? Well, it's to the left. That means it's smaller, so it's less than negative 3/8. Remember, the alligator wants to eat the bigger number. And down here we have negative 2. That's an easy one. I'm going to put that on there, right there. And then negative 16/9. That's an improper fraction. So let's change it to a mixed number. We do it the same way as with the positive, except we're dividing by a negative. We're dividing a negative number, which means we have a positive divided into a negative. Our answer is going to be negative. So this goes in negative 1 times, get negative 9, and then I have to, so it's negative 9 because I multiply the negative 1 times the 9, and then I have to subtract negative 9, which means I'm adding 9 to negative 16, and that is negative 7. Okay, so if you're not solid on your adding and subtracting of negative numbers, you need to go back and work on that. Come see me if you need help. And so then our answer is negative 1, and then technically it is negative 7, but you can't have a two negatives in your mixed number, so 7/9, negative 1 and 7/9. So we'll come here, negative 1, and then divide this into 9 sections. And we need 7 of those. 1, 2, 3, 4, 5, 6, 7. Right here. Negative 16/9. Okay, so negative 2 is less than negative 16/9 because it is more to the left. So if you have any questions about this, please don't hesitate to come ask me, or rewatch the video if you need to.